In this video, we do the integral of 1 over x to the fourth plus 4 dx. Also, don't forget to subscribe and turn notifications so you don't miss the video. Okay, x to the fourth plus 1, the denominator, can be written as x squared quantity squared plus 2 quantity squared. Then we're going to complete the square, so we're going to add 2 times x squared times 2, but because we're adding something, we have to subtract something not to change the original expression. So 2 times 2 is 4 times x squared. And because we completed the square, this is a square. This will be x squared plus 2, quantity squared. And then we have minus 4x squared, can be written as 2 squared times x squared, which is 2x quantity squared. So now this is a squared minus b squared, which is a plus b times a minus b. We're going to write the 2x part in the middle, so it's in standard form. So we have x squared minus 2x plus 2 times x squared plus 2x plus 2. Okay, good. So 1 over x to the fourth plus 4 is 1 over x squared minus 2x plus 2 times x squared plus 2x plus 2. So we're going to assume it's the form ax plus b over x squared minus 2x plus 2. We have plus cx plus d over x squared plus 2x plus 2. And why did we pick a linear expression on the top? Because it's 1 degree, the highest is 1 degree lower than the highest on the bottom, which is x squared, so it's going to be the power of x on the top. Okay, so now we can multiply by x to the fourth plus 1 on both sides. On the left-hand side, we'll just have 1. On the right-hand side, we'll have, so we're going to have ax plus b. So we're going to multiply by these two expressions multiplied together, which means for this one will cancel, and we're going to be left with this one. Okay, so we're going to have ax plus b times x squared plus 2x plus 2, then plus cx plus d times x squared minus 2x plus 2. Now, instead of expanding this out and then comparing like coefficients, we're just going to do it right now. So we're going to do x cubed first. So x cubed first. So we have ax cubed to start with. So we have a, then no other ones because ax is the highest power for the first one. And then for this one, we have cx times x squared, which is cx cubed. Okay, so now we're going to look at the x squared terms. So we're going to have, so the first thing we're going to have is 2ax squared, so the 2a, and then plus bx squared, so that's plus b. And then similarly on this expression, we're going to have minus 2cx squared. So we don't need the x, obviously. So minus 2c, and then plus d times x squared. And then we're going to look at the x terms. So the x terms will be, so ax times 2 is 2ax, so we just have 2a, and then plus b. Yeah, we're looking at the x term, so times b times 2, so that's 2b. And then here we're going to have 2c plus minus 2, minus 2d. So minus 2d times x. And then finally, for the one term, or everything without x, we're going to have b times 2, which is 2b, then plus d times 2, which is 2d. That's equal to 1. Okay. So from here, we know that a plus c is the x cubed coefficient, and x cubed is 0 on the right-hand side. So 2a plus b minus 2c, 2a plus b minus 2c. Then finally, we have plus d equals 0. Because x squared also has 0, we have 2a plus 2b plus 2c minus 2d is the x coefficient, so that would be 0. And finally, we have 2b plus 2d equals 1, because that has no x. Okay. So what does this tell us? That tells us that c equals minus a. That's good. So plugging that into the second equation, we have 2a minus 2c. So that's 2a minus 2 times negative a, which is plus 2a, so that's 4a. Plus b plus d equals 0. For the third equation, 2a, we can plus 2c, we can factor out 2, so we have a plus c, that's 0. So that would be 2b minus 2d equals 0. We have 2b plus 2d equals 1. Okay. Okay, so this tells us we can factor out the 2 and divide. So we just have b minus d equals 0, which tells us that b equals d. Plugging into the fourth equation, or the last equation we have, 2b plus 2d, so that would be just 4b equals 1, so b is equal to 1/4, and d equals 1/4. Okay, good. But now let's plug those both into this equation. So now we have 4a plus, well, b plus d is 1/4 plus 1/4, which is 1/2, equals 0. So 4a equals minus 1/2. So a equals minus 1/8. C is negative a, so c is 1/8. So we have all the values, the coefficients we need. Okay, so 1 over x to the fourth plus 4. On the first fraction, we have, in the denominator, we have x squared minus 2x plus 2, plus, on the bottom, we have x squared plus 2x plus 2. The first top part is ax plus b, and the second one is bx plus, or cx plus d, yeah. So we have minus 1/2, minus 1 over 8x, because that's a, plus b, which is 1/4, so d is also 1/4. And c is the opposite of a, so it's 1/8 x. Okay, good. Right, c is 1/8, yeah. So now let's look at the denominators of each. So let's differentiate it. So the derivative will be 2x minus 2, and the derivative will be 2x plus 2. And if we let u equals x squared plus 2x plus 2 on the second one, then if we have 2x plus 2 on the top, we can split that, and then that will be ln of x squared plus 2x plus 2. Okay, so let's factor out a minus 1/8. So we want 2x minus 2. But let's first factor out negative 1 over 8 and see what happens. We're going to get x, so we have minus 2, because 2 over 8 is 1/4, and negative, negative, positive. So we need to factor out another 1/2. So we have to multiply by 2, so that would be 2x minus 4 on the top, all over x squared minus 2x plus 2. And then we're going to do the same thing, 1/16. So we're going to factor that out. That would be 2x, because 2 over 16 is 1/8, plus 4, because 4 over 16 is 1/4, all over x squared plus 2x plus 2. Okay. Now we want to get 2x minus 2 and 2x plus 2 somehow. So that would be minus 1/16 times. So we're going to have 2x minus 2 all over x squared minus 2x plus 2. Then we're going to do minus 2. Minus 2 times minus 1/16 is plus 1/8. And so we're left with 1 over x squared minus 2x plus 2. And then we're going to have plus 1/16. Similar thing, 2x plus 2 all over x squared plus 2x plus 2. And then we're going to have plus 2 times 1/16, which is 1/8, times 1 over x squared plus 2x plus 2. Okay. So let's look at 1 over x squared plus or minus 2x plus 2. So this is factorable, as in x plus or minus 1 squared plus 1. And how do you see that? Because x plus or minus 1 is x squared plus or minus 2 times x, and then plus or minus 1 squared is just plus 1 is plus 2. So this works. Okay, so we're going to integrate. So we're going to integrate 1 over x to the fourth plus 4. Okay, so let's look at this one first. This is negative 1/16 ln, because it's 1 over u du. So it'll be ln of x squared minus 2x plus 2. Now, do we need plus or minus? And the answer is no. Because if you look at x squared minus 2x plus 2, we just found out it's factorable. So this expression is bigger than or equal to 1. So that means it's never negative. It's not factorable, but it's bigger than or equal to 1, which means that we don't need absolute value. Then on the last one, this one, we have the similar story. We have 1 over 16 ln of x squared plus 2x plus 2. And then we're going to have 1/8. Okay, so let's look at this again. So this will be x plus or minus 1. Now if we integrate this, okay, we can do a simple u substitution, and du equals dx. So we're just going to have inverse tangent of u, which is x plus or minus 1, and obviously plus c at the end. So this will be 1/8. Okay, so we're going to have inverse tangent of the first one is x minus 1, and the second one we have inverse tangent of x plus 1. And you can combine the ln's if you want to, but this is the end of the video. Hope you liked it. Thanks for watching.